sklearnpreprocessingLabelBinarizer. Description LabelBinarizer is a transformer in scikit-learn used for encoding categorical features as a one-hot numerical representation. It is particularly useful when working with classification algorithms that require numerical input. Inputs. Input 1 a 1D array of categorical labels. This array represents the raw categorical data that needs to be encoded. Input 2 a list of classes. This optional input specifies the unique classes that should be considered for encoding. If not provided, LabelBinarizer will automatically determine the unique classes from the input data. Outputs. Output 1 a 2D array of binary values. Each row represents a sample, and each column corresponds to a unique class. The value in a cell indicates whether the corresponding sample belongs to the class represented by that column 1 or not 0. Output 2 a list of classes. This list contains the unique classes detected by LabelBinarizer. Steps. Step 1 Class Identification. LabelBinarizer identifies the unique classes present in the input data or from the provided list of classes. Step 2 Binary encoding for each input sample. LabelBinarizer creates a binary vector where each element corresponds to a class. The element is set to 1 if the sample belongs to that class and 0 otherwise. Metrics. Metric 1 None. LabelBinarizer is primarily a data preprocessing technique and does not directly evaluate model performance metrics. Metric 2 None. Visualization plots. Visualization plot 1 None. LabelBinarizer's output is typically used as input for other algorithms and visualization plots are not directly applicable. Visualization plot 2 None. Fine-tune parameters. Parameter 1 neglabel specifies the value to use for negative labels. Default 0. Parameter 2 postlabel specifies the value to use for positive labels. Default 1. Uncertainty methods. Uncertainty method 1 None. LabelBinarizer does not incorporate uncertainty measures as it primarily focuses on deterministic encoding. Uncertainty method 2 None. Challenges and fixes. Challenge 1 Unseen classes if the input data contains a class not encountered during training. LabelBinarizer will fail to encode it. Sample use case that resulted in challenge 1 a dataset containing animal names, where a new animal species is introduced during prediction. Fixes to challenge 1 use a robust encoding technique like one-hot encoding, which can handle new classes gracefully. Challenge 2 data sparsity with a large number of classes. The resulting binary representation can be sparse, potentially affecting the performance of subsequent algorithms. Sample use case that resulted in challenge 2 a dataset with a wide variety of product categories, resulting in a sparse binary representation. Fixes to challenge 2 consider dimensionality reduction techniques like PCA or feature selection to mitigate the effects of sparsity.